January the 8th, 2015. Guys, with the things that we're seeing concerning the Earth's magnetic field, and we're looking at CERN and some of the other man-made catastrophes waiting to happen, and it looks like some of them are already starting to power up, and they're affecting the Earth's shields. And we need to take a look at it, because just back a few years ago, and still many scientists won't admit that the solar flares and coronal mass ejections will cause an earthquake. That science is not in their books. It's not in their terminology. It's not in their speeches. But since this is starting to affect our magnetopoles, it may not be a long-lived science, but we need to look at it, and this is what I do, and I've got some questions. But we're looking at the Earth now, and in order to get the magnetopoles and the magnetosphere into this image, we're going to have to shrink this down. Let's take a look at this. Now, when the sun hits the Earth, the magnetopoles is activated. That's the gyro that creates everything as we know it as far as life on Earth. The rotation, the gravitational field, magnetics, everything, the weather, space weather affects Earth weather. Take a look at this. It's a magnificent thing to comprehend the size compared to our planet. The planet's roughly, I think it's a little over 8,000 miles across there, and you see the sun come through. And that the sun controls everything. It hits the magnetosphere of the Earth, causes the rotation, everything. If the sun died, guys, the Earth would stop turning, life would stop existing. But let's look at some of the data on this, because of the reason I'm showing you this is because, like I said, there's a new science, there's new calculations that have to be thought about. Now, first, the magnetopoles of the Earth goes out about 40,000 miles. That's an average day. Your bow shock goes out about 15,000 miles further than that, at about 55,000 miles. Again, that's that outer white gray line that we're looking at. Inside that's your plasma sphere, your Van Allen radiation belt, and then you go down to about 100 kilometers and start getting into the Earth's atmosphere, and we're going to look at that a little closer. Now, the tail end of this, you're looking at 40,000 miles on the front side, or the sun-facing side, against the pressure, but it can go out about 3.9 million miles in the back side as it streams out the back, guys. But that's your northern tail and southern tail lobes. But we need to, again, this is starting to change. The instruments are indicating it, and I want to look at some of the things that we're dealing with and how it will affect it. Now, it's later in the afternoon, after 8 hours of complete chaos with the magnetopoles. That inner line is where the satellites rotate, 22,400 miles, the geosynchronous orbit, guys. That's where a lot of you, like your direct TV, things like that. But at 1:02 universal time, we started seeing a collapse in the magnetopoles over the North Pole. 3 minutes later, we see the meteorite explode over Bucharest. Now, whether or not this is connected, I don't know. But there's some questions I'm going to bring up at the end of the video about the compression effect from out into the magnetosphere and the magnetopoles all the way down to the troposphere where our weather's created, and that's important. But let's look at this. For 8 hours, again, let's remember that number as we look at that into the future, this occurred. Now, look at this compression, guys, almost perfect symmetry as it collapses the entire plasma sphere behind the planet down to this line. Check that out. To the right is the average, but you're looking at 50% compression, 50% increase, doubling the compression. That's important. Remember that, 50%. Now, at that point, when it compressed the top and bottom, 5.4 on the South Pole at the Balleny Island region. At the top in Iceland, 5.1. When you press the top and bottom, we had a 5.5 in Japan. Yesterday, double compression. Look at that. That's at least 16,000 miles above Earth. That double compression caused that 6.6 earthquake on the equator, guys. When you press it again from both ends, the pressure has to go somewhere. But notice this, 31 miles at 50 kilometers, that's the minimum distance of where the meteors start to burn off. From there to 85 kilometers. That's much lower than the space shuttle at 268 miles or the start of the exosphere in the upper atmosphere at 372. But again, 31 miles, these meteorites, that's kind of the bottom point of where they burn off. Down the center of this graph, you see it in millibars. Here's the question. Now, it's actually a typo here, because here's the question. What would be the compression ratio in the lower sections of the Earth with a 100% increase on the magnetopause? Because it went from 40,000 to 22,000 down to 16,000. So we double the pressure. How will it affect this 31-mile range of the meteorite burn-off? Will that drop also? But now, we got different masses involved in different millibars of pressure. At the bottom, 1,000 millibars, that's your average at the surface of the Earth. Notice Mount Everest on the right, the troposphere. When it goes below that, you see it in hurricanes, 99, 98, guys. How will that affect it? When you decrease that channel of the troposphere, the winds have to increase. Now, we're doubling the pressure on the outer edges, as you can see as we go through the day. Again, this occurred 8 hours. We're doubling the pressure there. We're dealing with different masses. We're different pressure in millibars. So it will not be a straight ratio. But notice this bend. It's against the natural flow of the magnetosphere, guys, when it pulls in. Something is not right. I've been watching it too long. Now, starts back to normal after 8 hours. Let's start watching this. It takes about that long every day. Yesterday, it collapsed for 4 hours within the satellite band. Again, it's around 16,000 miles above the surface. Should be 40,000 miles. So you're going to be above doubling the pressure at that point, guys. So when that happens, ultraviolet radiation, tectonic plate pressure, electromagnetic field shield damage for these meteorites and asteroids that they're saying is increasing now. But again, those questions are there, and it's kind of a new science. If you got any answers, again, take a look at the video. If you got to back up to the question section after looking at it, I'd like to hear your response, guys. Heads up, be safe.